Hello, everyone, and thank you so much for joining us for another VES-Artex Academy webinar. My name is Annie Lauber, and I am your host today. And today I'm joined by Dr. Borbala Foris of the University of British Columbia's Animal Welfare Program. We're really excited about the presentation today. Before we go ahead and get started, just one housekeeping item. We will be taking questions throughout the presentation. So if you have a question on something that Dr. Foris is presenting, please type it into the Q&A box on your panel at the bottom of the screen, and then we will address them at the end of the presentation. And with that, the floor is yours, Dr. Foris.
Thank you so much, Annie, and thank you to VES-Artex for inviting me today to talk about monitoring behavior at the individual level in group house cattle using smart barn technologies. So nowadays, as most of you probably know, many objects have a tendency to become smart, and barns are not exception from this rule. There are several systems available to monitor the barn environment itself, so temperature, humidity, airflow, light conditions, and there are also quite a few devices on the market which we can use to monitor production-related traits in cows, so milk production, activity, heat detection, rumination logging. And these smart systems come with the promise that they will help farmers to make better decisions, they can make production more efficient, and often it is also mentioned that having all this data can help to improve animal welfare. However, when it comes to improving the welfare of cows, measurements on the individual level are highly important because it is the individual that experiences positive or negative states as it lives its everyday life. And despite all these advances in smart monitoring systems, we don't currently have a touchscreen conveniently on the side of cows to ask for status updates. And I also don't expect this to come very soon. So what can we do? In theory, these smart technologies can provide means to eliminate risks associated with poor welfare. And these can also enable the cows to have more positive experiences. But it is unlikely that we will find just one magic welfare measurement device because animal welfare itself is a multifactorial concept. So today, I would like to talk about two approaches where we are kind of pushing the boundaries of technology to understand the experiences of individual cows and improve their welfare. The first topic I would like to touch on is measuring brush use, and the second is measuring social behavior. Well, everyone who has given a brush to a group of cows knows that they tend to really like it, and it gives them a good opportunity for scratching, which could otherwise be difficult in a barren barn environment. Well, but how much exactly cows value these brushes? One way scientists can find out what value a resource has for animals is motivational testing. So this study that you will see in a second applied motivational testing to find out how much cows value mechanical brushes. The way we do this is we put weights on a gate and cows will have to push this gate to get access to a brush. And with this method, we can ask the cows what is the price that they are willing to pay to get access to a brush. And we can also compare it with other resources. So you can see in this video how this works. The cow comes, has to push the gate, and then she can get access to the brush. So in this study from Emily McConaughey and her colleagues, they tested cows and found that cows are willing to push as much weight for a brush as they are willing to push for fresh feed. This indicates that indeed, cows put a high value on getting access to such a nice rotating mechanical brush. So we know that brushes are highly valued by cows, but why do we think that brush use could be used as a welfare indicator? Well, even though brushes are a valuable resource, we can argue that it's not essential for survival to have access to a brush. So if an animal is in a compromised state, we can expect that brushing, a so-called low resilience behavior, will start changing earlier and also recovers later than other core behaviors such as feeding or drinking. Following this idea, brush use could be a promising early marker for welfare. But in order to achieve this, we have a couple steps that needs to be taken. First, we have to obtain practical measurements on individual brush use. We also have to understand what normal brush use means for each individual. And there needs to be an evaluation of the relationship between individual brush use and the welfare of cows. Okay, so before I show more details to you about brush use, let's take a quick break and see what we know just from the top of our heads about the brush use of cows. So thanks, Annie, for launching the poll. And please answer the question, what is the average daily brush use duration of a cow?
We'll give it 10 more seconds or so as answers are coming in. All right, so it looks like we have 8% of people saying 1 to 2 minutes, 23% saying 5 to 8 minutes, 46% at 30 to 40 minutes, 0 people thought it was 1.5 to 2 hours, and about 23% said, I have no idea.
Thank you so much. Well, that's a great distribution. I see the highest percentage was for 30 to 40 minutes. And honestly, I don't have a clear answer for you. I would say it depends. But unfortunately, we don't exactly know what it depends on. Studies available up to date have found durations ranging anywhere from 2 to 7 minutes. Other work has found 20 to 30 minutes. And we have a couple ideas what could influence brush use, but it's really hard to compare these studies because they have provided different cow to brush ratios. The brush was placed at different locations. Some animals had health compromises, and all of these things can possibly influence how much they use the brush. So we don't exactly know. But there are some studies that give us an idea how brush use of individuals could change when they face different welfare challenges. So in this study, Ben LeCorb and his colleagues looked how the brush use changes when heifers are introduced to a new group of unfamiliar cows. So you can see in this plot, when heifers were tested individually and they were given 10 minutes of brush use every 2 days before and after regrouping. The baseline value was established before regrouping. You can see it here. And 8 hours after they have been introduced into a new group of unfamiliar heifers, which we argue can indicate a negative affective state and is associated with a considerable amount of stress, their brush use dropped. Then a couple hours later, at 56 hours, it recovered. And after that, they went back to their home pen. And this recovery continued, and it went back approximately to the baseline level. Another study using a similar methodology looked at how the brush use of cows changes when they are experiencing the considerable amount of stressors associated with calving, separation from the calf, and being introduced into the lactating cow group. Again, here a similar methodology was used with individual brush use tests, and cows were given access to a brush every week for 10 minutes, and their brush use duration was measured. You can see that it took them a while to really take advantage of the brush. They argue that this was due to habituation, and the baseline level was reached at around 1 week before calving. And then immediately after calving, 2 days later, when they were tested, the brush use showed a significant drop. And then again, as time passed, it started recovering, but it hasn't quite reached the level which was detected before calving. And also other studies that have been performed found association between brush use and lameness. Again, severely lame and lame cows declined their brush use. There was also an association found with metritis. Metritic cows declined their brush use. And again, with the hot temperatures, cows overall tended to use the brush less. So if we look at these studies and try to piece the evidence together, there is some indication that this brush use could be a useful indicator for us. Also, in order to use brush use as an indicator, we have to understand how the brush use of cows is influenced in healthy animals. In this study that we performed, we looked at dry cows and they were all healthy. And we tried to understand how dominance influences how much cows use the brush. You can see in this plot that dominant cows, which are shown with blue, throughout the day had higher brush use levels than subordinate animals in the group. Interestingly, these differences between dominant and subordinate cows were not related to direct competition at the brush. So it's not that dominant cows just pushed away the subordinate cows. subordinate cows had the opportunity to use the brush, but just did not take advantage of it. So overall, these studies give us some hints about what could cause variation in how much cows use the brushes. But we still don't have a comprehensive picture about how brush use could become a practical measure. And one reason for this is that commercial brushes come in many forms, but to date, they are only good for the cows to get a scratch, but they are not really give us any data. We cannot take advantage of them as a source of information. So here at UBC, we decided to develop and test a smart brush prototype that could detect which cow is using it and for how long. The idea behind the smart brush is fairly simple. We have two sources of data that we want to rely on. The first is rotation. We took a simple electrical brush and equipped it with a computer unit that was able to detect when the brush arm was deflected and the brush started rotating. So this device gave us the rotation direction and the start and end time of rotation events. In order to be able to assign these rotation events to individual cows, we tested two different approaches. First, we attached two large RFID antennas above the brush, which could read the ear tags of cows and transmit this information to the computer unit on the brush. In addition, we also used the computer vision approach, where we installed a camera above the brush. And this camera was used to detect simple barcodes that we attached to the collar of each cow. You can see the example in this picture, how the barcodes were put on the collars. So using barcodes to identify the individuals is a relatively simple technology, and it has also been used in animals much smaller than cows, such as bees or small birds. And it has the advantage that unique barcodes are very easy for computers to read. And this can save us the time that it would require to train an algorithm to recognize individual cows based on, for example, their coat patterns. So this is a fairly easy to start with approach, which we applied in this study. Then the aim was to combine these two sources of data to determine how much individual cows use a brush in a day. So with this smart brush prototype, we did some initial investigations first to better understand the factors that influence brush use. The nice thing about this is that the rotation data alone is fairly easy to detect, and this measure can already give important information for farmers about how their animals engage with the brush. So in this trial, we only used the rotation data and gave one brush to groups of different size and tested the brush use at two different locations, in a back alley and in the feed alley. And we also looked at how the brush use changes within different environmental conditions. One replicate was in the fall and the other replicate was in winter when the temperatures were colder. What we have seen here is that the average brush use per cow tended to be higher when the group size was smaller. Cows also used the brush more when it was placed closer to feed. Those are the blue dots. And overall, the brush use declined when temperatures were colder outside. Those are the triangles in this plot. Coming to the individual detection, what we found is that the computer vision-based approach clearly outperformed the RFID setting. And mostly this was due to the fact that these large RFID antennas were still not able to detect cows properly in all the different angles that cows were able to approach the brush. So we assigned cows rotation events based on the barcode detection before, during, and after the brush use events, and summed these up for each individual to get the total daily brush use duration. You can see in this video an example of how the detection works from the top view angle. You see that the brush swings, and this swinging of a huge metal piece largely limits the detection of the RFID ear tags, which you can see here. But you can also see that these little red squares, green squares pop up, meaning that the barcodes are properly detected using the computer vision technology. So when we looked at the relationship between overall brush use duration detected by this smart brush technology and our video observations, we found a very strong correlation. And we concluded that this could be a promising method to investigate the individual brush use in a variety of settings. So we can hopefully see and get a convenient way to understand all the different factors that influence the brush use of cows And hopefully we will be able to get at an early warning system indicating different welfare issues that individuals may face. Just a second. So moving on, let's talk a bit about the second area where we push the limits of smart technology with detecting social behavior. In the everyday life of cows, regroupings are very common, and they also often face competition when accessing important resources such as feed or water. And agonistic interactions can often happen in this context, which can cause social stress for animals. If we can measure and understand how individuals deal with social competition and social stress, we can hopefully identify vulnerable individuals, and we can account for these differences in how cows deal with social stress when creating groups. Feed-related competition and dominance can be measured automatically in research facilities, and this is what we have taken advantage of. These blue bins that you can see in the picture give us detailed information on the feeding behavior of cows, such as the start and end time of visits, and also the amount of feed that cows consumed. Using this information, we can detect so-called agonistic replacements between cows, meaning when one cow feeds and the other one comes, pushes her, and occupies her spot. In order to achieve this, we use an algorithm that detects if there is only a very short time between the start time of two different cows at one specific bin, and this has been validated to indicate an agonistic replacement. On the next slide, you can see a replacement event on this video. Cow A is feeding here, cow B approaches, pushes her, and occupies her spot. So this is what we call a reactor and an actor cow. Using these replacements that we can detect automatically with little effort, we can also calculate the dominance hierarchy of the group, and we can continuously track when group composition changes, which cows become dominant and which cows are on the bottom of the hierarchy, and they may be more vulnerable to social stress. Being able to detect these agonistic replacements automatically over long time periods also made it possible for us to investigate how cows deal with social competition and how this changes when they become ill. Using this methodology, we were able to follow several cows during the transition period, and we characterized their social competition strategies. What we found is that cows were very consistent and different individually in their competition strategies, and these were characterized along two main components. One was competitiveness, and the other is asynchrony. What it means is that cows with high competitiveness scores were involved in many agonistic interactions, both as actor and reactor, and they spent a lot of time at the feed bung. However, interestingly, some of these cows also scored high on asynchrony. It means that they visited the bins mostly around times when very few others were present, but they still performed a lot of agonistic interactions. So this could indicate some cows which are prone to bullying behavior. On the other hand, we also found some cows which were highly synchronized, but they did not engage in as many competitive interactions. So they were able to navigate this environment in a more peaceful manner. We also looked at whether these competition strategies differ between cows that remained healthy throughout the transition period and those cows that developed metritis after calving. As you can see from this plot, the orange and the gray dots are kind of scattered all over the place. So we did not find any clear differences between cows that remained healthy and then they became sick in their initial social strategies. However, interestingly, those cows that developed metritis, showed with orange in this plot, about a week after calving, they were less stable in their social competition behavior. So they changed their strategies more when they were moved to the lactating group and also during the days before diagnosis. So overall, these results indicate that automatically measuring how cows deal with social competition and paying attention to these subtle changes in their behavior could be a promising way of early illness detection. And again, this comes back to the idea that similar to brush use, competition strategy itself could be a low resilience behavior. So cows don't necessarily change the total amount of feed that they eat, but they already make adjustments to how they compete. And this could be a way to assess their welfare compromises earlier than using core behaviors only. So we could get at some cows that are at risk of developing metritis before their milk production or before their feed intake would drop. Luckily, the social life of cows is not all negative. They are social animals and they are able to form preferential relationships. However, these are not always easy to maintain in the commercial system where regroupings happen according to production state, according to feed requirements, and so on. Nowadays, there is more and more focus on positive welfare, meaning that we don't only aim to avoid suffering for the animals, but we would like to provide them with opportunities to have pleasant experiences. And this becomes more and more important as the industry faces pressure from society to increase the welfare standards. So enabling cows to maintain social positive relationships could be one way to increase their welfare. Familiarity is one aspect that may have an important role when trying to mitigate the stress associated with regrouping and trying to provide cows with more positive social experiences. What you can see in these plots are so-called social networks. Here, the circles indicate different individual cows, and the lines between the circles, these connections indicate different social behaviors. So on the left side, lines between two cows indicate grooming behavior, so when one cow licks the other. And on the right side, lines between two cows indicate that they were observed as feeding neighbors. What we did in this trial is that we mixed small groups of familiar individuals together into one larger groups and observed their behavior after mixing. In these figures, those cows that are familiar with each other are shown with the same color. You can see here that the circles with the same color are kind of clustered together. What it indicates is that cows preferred familiar individuals as grooming partners and also as feeding neighbors after regrouping, and they tended to have less interactions with cows that they did not know. And this pattern was kind of persistent during the first week after regrouping and started to fade away afterwards. So the results of this study hint at familiarity as one potential way to consider relationships between cows and optimize our grouping strategies. But again, this data was acquired using the feeding system that I just mentioned before, and also using very, very time-consuming video observations. So if we are to implement some of these strategies and further test their practical applicability, we need better technologies which could be applied on commercial farms to get at some of these behaviors. One technology to detect social relationships and to take these into account when regrouping cows is real-time location tracking. This system works as like an indoor GPS, and it is more and more common also on commercial farms. Mostly it is advertised as an easy way to find cows in a bigger crowd, so to limit the time it requires for the farmer to identify and find the individuals for certain treatments. But these systems can also be used to get at some other things related to social behavior, depending on the resolution, temporal and spatial resolution of the data that we get. You can see in this plot, in this picture, usually these location tracking devices come with a tag, which can be either attached to the collar of the cow. Sometimes the ear tag can have this transmitter that gives a radio signal, which is detected by sensors installed in the barn. And with a triangulation method, the system can give the X and Y coordinates for each cows. So these detections of cow locations can be summed up over time. And we can see how much different areas in the barn are used by the cows, as you can see in this figure on the right-hand side. So you can see that, okay, these lying stalls were used for quite a long time, and then cows were also present for a long time at the feed bunk. What we can also do is, if we don't aggregate this data over time, but look at the temporal changes as cows move, we can possibly get at the agonistic interactions or events where cows are often in close physical proximity. So after further method development and validation, this could be a promising method to get at both social positive and social negative behavior in cows in a manner that is possible to implement on commercial farms too. Another promising area to routinely monitor social behavior is computer vision. So this study from Sweden, for example, looked at detecting social interactions in the waiting area of a milking robot. You see that key points on the cows are detected by the computer, And they were able to reach a fairly good accuracy in detecting events when one cow agonistically pushed the other away in this area. So this method or similar approaches could be an important way to understand how the dominance relationships in a herd influence how much cows can get access to a milking robot, which could have direct consequences to production efficiency in many systems. So up until now, I talked about why and with what technology we could detect these behaviors, but what can we do with all this data? In order to turn smart technology into something that is useful for farmers, data integration and visualization are key factors. And unfortunately, this is a component that often gets underestimated when developing smart barn systems. So to tackle with this issue when understanding social behavior, we at UBC teamed up with the Master of Data Science program, and we were able to develop in this collaboration a dashboard to visualize the social behavior data that we collected. This has been launched just a couple months ago, so it's still in the early stages, but I just wanted to give you a glimpse of what is possible. I showed you the social networks before. So in this dashboard, we can now in real time see how the social behavior changes in a group of cows and how the network connection between individuals change over time and with regrouping events. We can also see the dominance changes in the lives of individual cows over time. And this dashboard can help us to better understand the initial patterns in the data and to formulate research questions where we can then follow up on and investigate how certain markers change when the welfare of animals is compromised. Another thing we can do in the same dashboard is to visualize the behavior of individual cows over the day. So you can see in this plot, there are 2 cows visualized, and yellow indicates lying behavior, red is standing, green is feeding, and the blue is not really visible, but those are the drinking events. So using these visualizations, we can, for example, get an intuitive idea how cows differ from each other in terms of their daily time budgets. And this could also be a first step to try and see some how pattern changes emerge when, again, a cow becomes sick or they become lame, or after regrouping, or all of these stressors that I've been talking about. But only because we see something, we don't necessarily know what to do with the information. And this is where there is still a lot of work that needs to be done. So we need to really validate the link between the actual welfare state and the measured change in these candidate behaviors. And after understanding these relationships and seeing where the association between welfare and the change in behavior is the strongest, there needs to be a development for decision support tools that farmers can actually use. I'm optimistic that we can use smart barn technologies to make positive changes in the lives of cows. However, as a recent review from Dan Weir and Nina von Keyserling points out, we should consider a couple key things as we increase the technology used on dairy farms. In their review, they found that many papers to date involving precision livestock farming allude only to the positive effects of the technology on cattle welfare. But animal welfare is a complex concept, and it cannot be measured only by one piece of technology. So we should keep this in mind, and researchers assessing technologies should restrict claims to these specific measures. So we should really focus on the actual things that were validated and try to stay away from ending papers or making claims with a very general claim of, oh, this piece of technology can be used to improve welfare. Finally, I would like to draw your attention to another important area. This study has been performed recently in Europe, and they applied focus groups in Finland, the Netherlands, and Spain, and they wanted to get at the view of society on precision livestock farming. What they have found is that consumers expect that precision livestock farming technology will enhance the health and welfare of farm animals, contribute to generating environmental improvements, and increase the transparency of farming. However, consumers also feared that the increased use of technology could lead to more industrialization in livestock farming, that these technologies and data could make systems vulnerable to misuse and cybercrime, and the PLF information might be inadequately communicated to consumers and not necessarily help them to make purchase choices. So as we move forward to developing and validating smart technology, to get at the welfare of individual cows, we should keep in mind that all this technology will be measured also in the eyes of society, and we should strive towards developing methods that are acceptable for society, work for farmers, and indeed help welfare improvements of individual animals. In order to give you some key points from my talk, I would just like to summarize things briefly here. And I would say automatically monitoring brush use and social behavior in cow groups could be a promising way to improve welfare, but further developments and validation studies need to be done. And we need to validate how these changes in these behaviors relate to specific welfare concerns. It's also very important to develop informative visualization and decision support tools. So we cannot just stop at the level of proof of concept where something works in a research facility. In order to make impact in the real life of cows on commercial farms, we need to see through that these tools are actually developed to the stage where it can help the farmers to make better decisions. And we should keep in mind that the potential challenges and risks are involved when working with smart technology. And this technology can also pose challenges for animal welfare and the social acceptance of farming. So with this, I would like to thank you for your attention, and I'm very happy to answer your questions.
Thank you so much, Dr. Foris. The first question we have is, excuse me, do you think we should give more brushes to cows?
Well, that's not a yes or no questions. I would say if the question is, should we give brushes to cows that don't currently have one? Absolutely. But before I would say that, yes, let's just give more brushes to all of the cows, I would say, let's consider first where to put these brushes. And it would be important to better understand how the cow to brush ratio and cow placement together influences the brush use in different groups. And I think one key way to better understand this would be to have an actual product that could give us information on the brush use, maybe not on the individual level first, but just the overall rotation time. So the overall time the brush was in use. If we would have large scale data on the rotation time of brushes on several farms, we could be much better positioned in answering how many brushes cows need and where we should put them.
Thank you. So aside from the smart cow brush that you shared about today, there are lots of different commercial brushes on the market. Are they all truly the exact same? Are some better than others? Which has the best effect on animal welfare?
Again, this is a question that we just don't know, because as I know, none of these brushes are able to give any information on their use. So without having this information, we cannot really tell how much better one is than the other. Of course, we could do motivational testing and compare different commercial brushes. They differ in their position, whether they are vertical or horizontal, the angle that they can swing. And there are some differences also in size. And to my knowledge, there has been no studies directly comparing which brushes cows value more, for example, with motivational testing. But I would say, again, a much better approach would be to just get some data from all of the brushes available routinely, because that would give much more information for us, and it could help the development of brushes much more effectively than researchers trying to do a crazy amount of comparisons between slightly different models.
Thank you. So is there, oh, excuse me. Both the ear tag and the collar are on the head or neck of a cow. So if the cow rubs her back, is there a possibility that she may not be identified?
This is exactly something that we struggled with a little bit. And that's why we decided in the machine learning algorithm that we applied to detect individual cows that use the brush to rely on information both before the actual rotation event, during the event, and after the event. Because as we have seen in our initial video validations, cows most commonly activate the brush with their heads. And even if they do not engage with their heads at the beginning, at some point, the head will and the neck will be in the brush area. And this method then proved really useful. And indeed, we were able to find a strong association between our smart brush data and the video observations at the end.
Thank you. Have you seen changes in social behavior based on days in milk?
Well, this is, again, something that we can look into using our continuous data, but we haven't really looked at changes in social behavior in association with days in milk specifically, because the thing is, it's a very difficult question to ask on the individual level, because the lactating group often changes. So we not only have changes in days in milk, but there are also factors such as new cows being introduced to the group, other cows being taken out of the group. So there are several things happening at the same time. One thing that we looked at for a very long time in a dynamic group of cows is social dominance. And we haven't seen any consistent patterns of changes in dominance in a common dynamically changing group as days in milk change. So cows did not clearly become more or less dominant as they spend more time in the group and their days in milk changes. But this is just the start. So I hope that once these routine measurements are established, we will be able to disentangle all the different factors that can have an effect on social behavior. One of them is certainly days in milk, but this needs to be separated from the effects of group composition change and illness and so on.
Thank you. What are some of the welfare risks of smart barn technology?
Well, there are a couple of things in the literature that often come up. One is the expected change in the human and animal relationship. So as farmers rely more and more on devices, on computer technology to understand the behavior of their animals and to manage them, one risk is that they may spend less time in the barn. They may have less personal connection with the animals, or it can also happen that cows mostly meet humans and have human-animal interactions in a negative context where treatments are required, which cannot be administered by a robot. So one key question is, if smart technology gives more time to farmers, how do they use it? So it would be possible for farmers to use this time that eventually is freed up to go into the barn and have low stakes or no stakes pleasant encounters with their animals and just observe them without the stress of needing to do anything with them. But it can also be true that that the increased use of technology could lead to humans interacting with computers and animals interacting with computers too, without the animal-human bond being established in a positive context. So we don't currently know how this will play out, but this is one area of concern. The other thing is, which I see as a risk factor, is how well these smart technologies are actually validated before they are introduced into commercial settings. So there is certainly a risk involved when resources are limited to do validation studies. And I myself am often very excited when a new technology comes up and I see, oh, this is great, we can use it in so many different ways. But it's important to keep in mind that when something is introduced to farmers and we say that, yes, this piece of technology can help you in this specific way, that the validation behind it is robust. And when we come to animal welfare, this is especially a key issue because welfare itself is a multifactorial concept. There is no one welfare indicator that we will be able to have. So it's very, very important to be specific in this case and say, okay, this piece of technology can measure this behavior, and that behavior has been validated to change this and this way when an animal develops, for example, lameness or metritis. So it's more useful to be very specific about the claims that we make and the technology that we claim that the technology can do. And I think it's a risk that we tend to be vague. And if we just say that this technology can help welfare, it won't be any actual use for farmers.
Thank you so much. I'm not seeing any other questions, so we'll see if any more come in the last minute or so, but I just wanted to take the time to thank you again, Dr. Foris, for your presentation. It was extremely interesting. As well as I would like to invite everyone that joined us on this webinar to register for our next webinar, which will be on February 9th, 2023. It'll be with Joel Hornby, who works for us at VES-Artex as a key account specialist on building a better barn. So we would invite you to join us for that presentation. And with that, I'm not seeing any more questions. So I think we are good to wrap this up. And thank you so much again. And we hope everyone has a really great weekend.
Thank you. Bye.